Hi, everyone. I'm Devin Walsh. I'm the executive director of the Uniswap Foundation, and I am so happy to be here today. First off, congratulations to all of you. Give yourselves a round of applause. There were almost 150 of you that went through the program, and over the 2 months that have just passed, you learned how to build your first hook. That is huge. You are now amongst the first to understand how to use and build this new primitive that UniV4 introduces. So congrats to all of you, and also congratulations. And I want to acknowledge rorriM Academy. Round of applause for them for pulling together such an amazing program. The foundation was founded to cultivate the developer ecosystem on top of Uniswap. So the launch of V4, which really makes developers a first-class citizen in the protocol, is a huge opportunity for not only us, but more importantly, it's a huge opportunity for all of you, for all of the hungry developers around the world who want to make their impact on the world of DeFi and within the world of crypto. Trading is one of the core primitives of blockchains, but execution quality is still not on par with TradFi exchanges. And there's a whole world of different use cases to explore to customize or optimize or really enhance the experience of a given protocol, community, or asset. And that is a huge experience. That is a huge opportunity for all of you to create those experiences for all of the current and new users to come into the space. So in addition to that, I'm excited to continue to work with some of you. I think these guys have talked about the UF Ambassador Program, where some of you who have submitted capstones will have the opportunity to go to hackathons with Sauce and continue to learn from him and other experienced Uniswap protocol engineers and support other new developers coming into the space. And then I want to tease, we have a few really awesome programs that we'll be announcing before the end of the year that are focused on supporting developers just like you all, developers who are hacking on your next idea, who are exploring the design space and trying to figure out how to make your impact. So keep your eyes peeled for that. I think I opened up the cohort a few weeks ago by asking all of you to explore and have fun, meet your classmates, and hopefully, maybe meet some future co-founders. And I'm very excited to see what has emerged. And with that, I'll pass it back to these guys. And yeah, congrats again.
Amazing. Thank you, Devin. And yeah, it's great to see the circle complete with you opening up the cohort and seeing what actually came out of that. Okay, so now we'll jump into presentations. Each of these teams has spent a bunch of time preparing to talk through what they've built, and I'll let them take over. I'll just be the kind of MC between the presentations. So let's get started with LVR and IL Hedge Hook. Go ahead and share your screen and jump right in.
Perfect. Just confirming that you can see the screen correctly.
Yes.
Perfect. So Carlos, if you want to jump in.
Yep. Hi, everyone. So we want to introduce the LP risk neutral hook. Our proposal with this hook is to provide a combined solution to hedge impermanent loss and LVR via dynamic fees and hedges to achieve both delta and gamma neutrality. So let's go to the next slide. So there are two main methods of quantifying the loss LPs incur. Loss versus holding, also known as impermanent or divergence loss, and the loss versus rebalancing, also known as lever. While impermanent loss has been the primary metric for quantifying LP losses on Uniswap, it has some major drawbacks. It compares LP value to the value of simply holding the tokens, which is an unrealistic strategy. Furthermore, if the price diverges and then returns to the original price, well, impermanent loss is zero. So completely disregarding volatility. Lever, on the other hand, is path-dependent, meaning it takes into account rebalancing and arbitrage opportunities given a time series of prices. It occurs mainly due to AMMs having stale prices. We have two ways to solve this. Can we go to the next slide? Yeah, so first is using hedges. Due to the negative convexity of the LP value function, their positions cannot be hedged solely with delta 1 or linear products. However, for small enough price movements, a delta hedge can be sufficient to offset the lever. This can be achieved either by selling futures or via on-chain borrowing and setting a rebalance threshold from which, if surpassed, a re-hedge is executed. So for LPs that desire a complete hedge to offset all directional risk, products like power perpetuals or options are the preferred approach. And the other one is to dynamically modifying pool fees. So to correctly remunerate LPs and price volatility accordingly, as well as reduce price impact for large swaps and account for market conditions via gas price, a dynamic fee system has been implemented. To achieve this, we extract implied volatility of the pool from volatile asset drift and the return from pool fees using the formula derived by Daniel Alcaraz. With that, we attempted to devise a simple model that dynamically adjusts the fees with a discount factor based on the volatility risk premium. That is, the difference between implied and realized volatility. So whenever implied volatility is higher than historical or expected volatility, providing liquidity yields a positive expected return. And if the implied volatility is lower than the historical or expected volatility, the return becomes negative. And let's continue with Alejandro.
Perfect, amazing. So yeah, as Carlos mentioned, we're trying to devise a twofold solution. So we envisioned a dynamic fees approach, and our novel approach is, as he mentioned, using the volatility risk premium, the difference between the implied and the realized volatility, and also allowing LPs to hedge both delta and or delta gamma hedge, which can be done either by power perpetuals or the only delta can be done via borrowing or just delta one products such as futures. And then this is kind of a visual approach that we've taken. So basically, if you consider fees, you're moving the curve of the value of the LP above zero. That is the risk that LPs are taking. It's offset by fees. If we try to optimize that fees that they are taking, we can improve their profit. And then we can also offer market neutrality, being independent to market movement, right? So also, I just wanted to do a quick shout out to Atis, who I know is here on the call, and his math helped a lot. His articles were really, really helpful for this. So yeah, just moving forward, how does this work exactly, right? So, well, first of all, we need to comply to compute the implied and realized volatilities. We've done this via our providers, and I will get into the implied a bit further in the presentation. And then we need to adjust the dynamic fees in order to minimize the lever. Then we compute the Greeks for the LP, so this is the delta and the gamma, and we hedge the impermanent loss accordingly. And one thing that it's really good to do this automatically is that you can account for costs, abstracting that from LPs, right? So one of the hidden costs that LPs have is that in order to hedge DIL, they have to incur in either borrowing APRs or funding fees on futures, right? And we try to abstract that and do the more optimal approach. So this is the quote that Carlos mentioned by Daniel Alcaraz. And this basically outputs that the profit that LPs have is actually conditioned by implied volatility. So how did we try to model that? So we actually got the approach from Daniel Alcaraz himself. We're actually exploring the formula proposed by Guillaume Lambert, but this is the main idea behind the model, right? So this actually has to undergo a lot of backtesting and supervision. But what this formula tries to do, it's basically the dynamic fees are based on this divergence between realized and implied volatility, also called the volatility risk premium. When one is above the other, we change the conditions in order to either benefit LPs or traders and try to make it a little bit more risk neutral, right? So this is the actual formula for the implied volatility. Again, if you want to see a full derivation, you can go to Daniel Alcaraz article, or one thing that I will show in a minute. And then our proposed adjustment based in the volatility is the formula on the right, which you will have a full derivation of the formula properly explained in a formal document. So this is one experimental approach that we took. Volatility here is modeled as a stochastic process, and you can see the discount factor on the bottom. And again, these formulas are subject to a lot of testing still. So there's just a very early model, and we try to improve on this. So this is kind of the architecture. I know that we have very little time, so if you want to go over this in detail, it's linked on the GitHub, the full presentation, if you just want to go over the presentation or the code. And then, Carlos, if you want to jump in here.
Yes, of course, there is much more to be done here, right? So from the part of the development, we need to complete the contract to handle hedges, implement threshold tracking the delta hedges, and track real costs for delta and gamma hedges. of course, use and add the connectivity with external protocols, Chainlink, Brevis, EigenLayer, and there are a few others that we have planned. And absolutely testing some adjustments, and then further research with studying the real VRP effect on fees. And there is a solution that we have in plans that is create a backend to abstract computations from the blockchain to reduce the gas usage. And ideally, at the end, or maybe at some point, is just to design the front end so that the LPs utilize the hook as well. Can we go to the next slide, please? And besides that, as a security company, we are also, we have more plans of development. We have a plan for a CK hook. We have a plan also to offer the hook development as a service for anyone else that is in need of this. And as well, thanks to the opportunity that the incubator has given us, now we have gained an amazing knowledge on hooks and Uniswap before. And that's why we are also able to provide audits for any hook development in our company. And yeah, that's me. Alex, can you go next?
Perfect. Yeah. So furthermore, we just didn't want to do just the hook. So we wanted to give something back to the community. So what we did is a document that it's a mathematical primer. So this is basically a document that goes over all of the mathematics for Uniswap, and you have this on the GitHub. I will just go over these really, really quick. So basically, you will find a PDF, and you have all the mathematical derivations from scratch, just from the constant product formula, up to modeling with stochastic processes, the expected values of the IL, and all of the graphs and charts that you've seen in the most important articles, as for example, at these ones. You will have them here. You will have also some novel ones. And every single formula is derived step by step, because one of the things that I found is that many of the articles say that derivations were trivial, and they were far from trivial for me, some of them. So we just have this step by step. And we also provide some videos on the GitHub. So with a detailed functioning on how the protocol works, made with Memediction, that is basically a Python framework, so that the community can better understand the inner workings of the protocol, and they can visually understand what all of these concepts mean. And basically, for example, here you can see the derivation of impermanent loss based on the LP value provided. So we will also be providing both the videos and the code to generate these videos that you can see on the left. And yeah, we are basically a team of three. One of it's me, one it's Carlos, and one it's Sergio, who is a bit shy and didn't want to speak up today, but he's here. So these are the three of us. And any doubts that you have on the code or on the concepts, you can reach out, and we'll be more than happy to answer. And here is the repo. Of course, the link is public, and I think that's just everything. So thank you very much, and we hope to continue with the hook and inspire someone with it.
Amazing. Great job, guys. Just take a second to celebrate yourself from reading the comments in the Zoom chat. Next up, we have UniCord.
1 second, do you see my screen?
Yes.
Yeah, so hello, I'm Yevon from team UniCord, and we are building a yield maximizing hook. 1 second. The problems that we're trying to solve is the capital efficiency of traditional stablecoin pools. For example, in top of 6 pools for USDC pair, you can see DAI USDC pool, which is at a VL of 73 million, with almost zero yield, annual yield. Also, you have USDT pool, for example, with 22 million, with a little bit higher yield, but only 1.67%. So in total, it's 100 million of TVL with almost zero yield, and which is quite capital inefficient. And our solution is replication. No OP hook that deposits all of the liquidity, all Uniswap liquidity in the stablecoin pool into Morpho to earn interest rate with on-demand withdrawal of trades. It works very simply. Our hook deploys all the funds into Morpho, 100% of the liquidity. And if some swap occurs, we just withdraw this liquidity from Morpho and give it to the user, which in turn adds from 6 to 9% very low risk yield on top of trading fees for LPs, in turn significantly boosting LP returns from almost like 0 to like 12%. And as for the impact, this additional yield will attract a lot of TVL from competing projects, especially when we are looking for Curve, which is a big project, one of the top projects, the TVL of which can be employed much more efficiently. And this approach has also potential for non-stable coin pools, for example, ECUSDC pools or BTC Ethereum pools, where you can deposit all of the assets that you use for your liquidity provider into Morpho to earn additional very low risk return, which in turn optimizing yield across diverse assets. As for the extension, we plan to integrate for diversification and support multiple lending protocols beyond just Morpho. For sure, it will be Aave, Gearbox, Euler, Fluid, and other projects. So this way we can diversify our counterparty risk and yield risk. As for the team, it consists of me, Yavan, who is about math and memes. I previously worked as a quant and designing market making algorithms, and was a project owner at another service provider. Also, I have Ivan, who's a lead developer, winner of 5 blockchain hackathons. Previously, together we built Liquidity Hedge Hook, which is exactly the first project from this academy, like synthetic Ethereum vault on top of Uniswap V3, which utilizes Power Perpetual futures to hedge impermanent losses. Also, back in 2021, during Hack DeFi with Intermute, we built customizable hooks DEX, which was a proto version of Uniswap V4. As for the next steps, it's to receive grant for audit of these hooks, launch it for production, and kill Curve. Yeah, that's it. Thank you for your attention.
Thank you. And yes, it's great to be able to have alumni from previous cohorts come back to keep building hooks. So congratulations on both winning a prize in the last hookathon and coming back for another project. Next up is cross-chain liquidity operator.
Are you able to see the presentation?
Yes.
Perfect. Yeah, hey everyone, I'm Ulysses. Very excited to present our project today for the Uniswap Hook Incubator. It's the cross-chain liquidity operator, also known as CCLO. It's a project by Zach, my teammate, and myself. Zach is currently the head of product at Arcadia Finance and previously headed machine learning at V Group and P&G. As for myself, I do software and research engineering in crypto, was previously at Chainlink Labs Research, Binance, and Cloudflare. I want to start this presentation off by showing this chart, which clearly shows how the usage of L2s has proliferated over the past year. Just a year ago, the total value locked on all L2s was about $9 to $10 billion. And right now it's at about $36 billion, which is more than 3 times the original amount. So lots more people are using L2s and lots more applications are also on L2s. And so why is this a problem? This is a problem because liquidity is currently fragmented across the many different L2 ecosystems we have. And with the rise of the different L2s such as Arbitrum, Optimism, and more, users are constantly moving their funds across many different chains to explore and also use different applications. And this introduces large amounts of liquidity fragmentation, where doing a swap on one chain can introduce large amounts of slippage. This is bad for users because once they move their money to a certain chain, they would feel locked in because they don't want to move it around that often. And also frequent bridging introduces vulnerability from smart contract hacks and also make like an overall unpleasant experience for the user. This is also bad for developers because developers that are developing on chains that typically have lesser liquidity can mean that they also have lesser users because users tend to follow where the liquidity is best. But we can make it easier to share liquidity cross-chain with the current technology that we have. So Uniswap V4 introduces hooks where we can run arbitrary logic before and after different actions, such as a swap or modification of liquidity. And so CCLO is a hook that is designed to allow for chain abstraction and also greater sharing of liquidity across different chains behind the scenes by providing a seamless integration. So with CCLO, users can provide liquidity across multiple chains simply by interacting with a single contract on one chain. I'll now pass it on to my teammate to talk about the architecture for a hook.
Hello everyone, I will talk about the architecture a bit more in detail, what we did. So to make the cross-chain happen, we use the CCIP chain link. So when the user is initiating liquidity provision with a specific strategy from chain A, first we inform the pool manager of new liquidity delta on chain A, which needs to be deployed on the chain A. And then we send what needs to be sent to chain B. To the hook sends the cross-chain message using CCIP to chain B. So then CCIP router is communicating to chain B, and then the router communicates to hook, and then the hook is deploying the liquidity for that user in the chain B, that without user interacting in the chain B. Moving on, we put some code snippets here that is more like relevant here to that it happens all in the one single hook, that the sending the message and receiving the cross-chain message happens one single from one single hook. That is more like in the second and the third code snippets. We deployed our hooks on 2 chains that we can see in the next slides. Yeah, we deployed to test on base Sepolia and Ethereum Sepolia to testing our design, and as you can see that the hooks addresses are there, and you can see also from our GitHub repo later on. And we made a simple front end for interacting with the hook, and all tests are passing. But since we had some limitations in time, we couldn't do everything we envisioned from the start. So moving on to the future improvements. So as a future improvements that can be done, we see as a complex strategies can be done. Since we did it on the 2 chains, but as a design, we did it to work it with 2 or more chains. So it can also be 3, 4 different chains. Just-in-time liquidity provisions can also work with our hook. So when the user wants to swap through in one chain and there is not enough liquidity can be moved from other chains as well. And then we want to also improve on the future for the dynamic strategies, to use maybe on-chain data for the volume, depending on that, doing the strategies. And we did only for adding liquidity, and in future we want to add also the removing the liquidity cross-chain. So that's it from us. Thank you for listening.
Thank you, team. Next up is Melody Pools. And before they go, just a quick reminder, in the chat, I have posted links to the project pages for the presentations that have gone so far. In those pages, you can see links to code, repos, the actual presentations, and more. And we'll keep adding to that as presentations come up. But let's kick it off to Melody Pool, or sorry, Melody Pool.
Cool. Thanks, Vamik. My name is Moran Haidari. I'm currently a founder at Arena Exchange, but today I want to talk to you about Melody Pool, the hack that I did for the Uniswap Hook Incubator course. So yeah, Melody Pool is basically an implementation of dark pools. Dark pools essentially allow people online to facilitate trades without compromising any of their privacy. So that means orders that they make, their wallet positions, etc., should all be hidden until their swap gets facilitated on-chain. So the hack basically is composed of a UI in EigenLayer AVS that's custom for the Melody Pool project, and then 2 smart contracts, a hook contract, and a router contract, which I'll dive into in just a sec. So the UI is quite simple. There's a few things that the order entails. One of the things being a permit to operation, and then there's the actual swap details in regards to what the user wants to buy, at what price, and all that kind of stuff. The UI basically walks the user through the permit to operation creation, and then taking that detail, hashing it in some way with the rest of the order details, and then it interacts with the EigenLayer ABS that we've created. So in this case, we have a simple UI that lets the user set their swap details. They connect their wallet. The first signature that they sign is a permit to operation. We get that information back, and then we take the rest of the swap details, put the permit to object as well, and then we send it to the AVS. I think this table only shows 10, and I didn't have it dynamically update, but this did get added to the AVS. The AVS, we interact with it using a GraphQL API. So we take the swap details, send it to the AVS, and then the AVS basically has two roles. One is a Node.js server with a GraphQL API that interacts with the distributed PostgreSQL database, and this just stores hashed order data until specific conditions are met for the swap on chain. And then we have a hook contract that's deployed on whatever chain that's emitting events every time people trade using the hook. And so the other thing that the AVS has is a listener that just gets updates from the hook every time prices are shifting on chain. If conditions are met, it'll go through the hashed orders, because we store the hashed orders, but a few other metadata as well. And if a trade condition is met, the AVS operator is responsible for invoking a swap function in the router contract. So there's two smart contracts. One is the hook. The hook is responsible for emitting the events every time someone swaps, or initially, like when people add liquidity. And then the other contract, which is the router, is able to take a hashed order, parse the permit to operation, parse the signature, and validate a few things on chain before actually facilitating the swap. Once the signatures and the ownership of the order is validated, it actually invokes permit to, which then takes the liquidity from the user's wallet to actually facilitate the trade on chain. So the trade intention, the wallet positions, etc., don't get exposed to the broader market until the swap conditions are met that the user that's trading actually set out. Here's a very high-level overview of the contracts that are involved, what's on-chain, what's off-chain. So we have the two contracts. We have the order manager that inherits various things from Uniswap v4 and EigenLayer, just to do a lot of validation, order updates, and all that kind of stuff. And then the router itself is just able to parse hash data and call Uniswap v4 as needed. In terms of what's off chain, obviously the UI right now is being served using Vercel, just because I'm using a Next.js app. And then if you want to be a Milady Pool operator, you would run a simple Node.js app with the PostgreSQL database. And then as people are making trades with the UI, you're responsible for having the operator running and listening to on-chain events, so that if an order becomes valid, you send the order on-chain. Since this was a hack, there's still a lot of work to be done. A few things that I want to do. So dark pools, the whole purpose of them is to keep everything private. So I did start some work with ZK proofs with SP1 by Succinct and Succinct smart contracts, but wasn't able to integrate that into the hook contracts that I've created. So getting that put in place. I also want to add fees. Why run an EigenLayer operator if you're not getting money out of it? So just designing a token incentive model to have people run operators and maintain the software while people are able to, or people submit private orders, supporting additional order types, and aligning closer to the AVS node specs as specified by EigenLayer. And then because this would be a end-to-end production app, just being able to complete audits and test the thing end-to-end to make sure that it's usable for everyone. Yeah, that's all I have for today. If you guys want to learn more or contribute to the project, feel free to reach out to me online. Thank you.
Amazing. Great job. I know Ken at UF was particularly impressed by this project, so very excited to see this. We're going to take a quick halftime break where we play a video from one of the presentations. And it'll be obvious once I hit play why we're doing this. So this was submitted by this pretty badass team that contained 2 people that work at labs, as well as a few other people. Fahad is actually organizing a great conference at Columbia with the foundation, so excited to see that. But I want to play this video because it was so entertaining. Let me make sure audio is shared 1 second. Yep, audio shared.
Oh, it went to 0. Damn, there we go.
Are you tired of getting rugged? Tired of waking up and finding out your favorite meme token just inflated its supply and left you holding the bag? Does launching a token feel like navigating a minefield of insider tricks and supply inflation? Not anymore! Introducing Dump No Fun, a rug pull resistant hook. The token launching tool that guarantees a fixed supply, no shady insider allocations, and built-in price support. With Dump No Fun, you can deploy your ERC20 tokens through a verified launch process. No more minting tokens after launch, no sneaky insider deals, and no sudden inflation surprises. Oh yeah! I need it! Come on! Give me some more! Rug pull resistant hook! But what if the issuer tries to mint extra tokens for themselves later? Not with Dump No Fun! Once you launch, the total supply is locked, ensuring everyone plays fair and square. Got a shady developer trying to inflate the supply? Nope! Not with Dump No Fun, the rug pull resistant hook. And that's not all! When you launch your token, Dump No Fun allows for instant trading on Uniswap, and the entire supply is locked along an issuance curve for 30 days! This gives your investors the peace of mind that price support is built in, preventing rug pulls and sudden dumps during the lockup period.
The deploy pool function creates the token, initializes the pool while attaching the hook, and locks up the capital. The hook enables before initialize, which reverts always but for hook library in v4 core. It isn't called when the pool is initialized directly by the hook, and thus only the deploy pool function from the hook can actually attach the hook to a pool, and this function uses a fixed minimalistic specification of an ERC20 ensuring that the token supply cannot be inflated. Moreover, the initial hook liquidity is kept under the hook address, and therefore can be withdrawn only by calling a special hook function, withdraw liquidity. This function, withdraw liquidity, enforces the lockup period and ensures only the token creator can retrieve their capital. All other liquidity modifications would need to go through their own routers.
Launch your token the right way with Dump No Fun and keep your investors confident! Say goodbye to those pesky rug pulls and hello to safe, secure, and verified token launches. Protect your investors with Dump No Fun today!
Okay, based on the number of comments I see, I didn't even read them. It seems like it was worth it for that halftime break. Thank you for that. And this is also a good time to plug the projects page. If you ever want to look up any projects, you just go to projects.hrm.com, click on this page. You can see all the links about it and you can share them around. So if you want to watch that video, it's embedded right here. Feel free to share it around. Okay, next up is RaffleSwap. I'll let you take over with the screen share.
Hi, Dixon here. Can you guys see my screen and hear my voice?
Yes.
Fantastic. So name's Dixon. We are a team of 4 with Francesco, Dennis, as well as Alex. We are a composition of people across multiple domains, cybersecurity, access protection, and even stablecoin projects. So unlike some other previous projects that emphasize a lot on the technicality side, we would like to instead to play around with hooks to introduce a kind of experience, which is simply raffling. And we would like to ensure that everyone will be able to raffle to win. So let's start with a little bit background. The key thing that we would like to kind of resolve is about toxic order flow. Basically, we all know that is definitely bad for LP in general, and it would likely be especially bad for stable pairs. So in order to mitigate this, we have been on and off introducing things like say dynamic fee. But dynamic fee may not be necessarily a solution to some scenario where, and it may actually kind of, at least we think that, it may actually make the LP sounds a little bit incompetitive to certain scenarios, say if when the trader actually want to kind of just do whatever aligning to the market does. And dynamic fee is actually introducing or encouraging the opposite. On the other hand, if we would like to, encouraging uninformed trader, people may consider, a reward-based, swapping mechanics. So the more you swap, the more, reward token. But our team also see this may be introducing a little bit, capital efficiency, basically because you will then subsequently need to find some way to introduce certain value, intrinsic or external one, for those particular tokens in order to make the reward mechanics sounded. So instead, we would like to present to you RaffleSwap. Basically, our goal is very simple. We would like to drive more uninformed trader, and hopefully with such, the position of the price will be automatically adjusted sooner and hence less exposure to TOF. And one thing that worth noting is uninformed trader, per our understanding, is that they are much more likely insensitive to prices. And this is exactly the feature or the attributes that we would like to kind of build. We will charge some additional premium. For now, it would be 1% for a price or premium to kind of collect it for the pot, and then in exchange we will give those trader a ticket for the raffling later. So every time that once we manage to collect a bunch of tokens, tickets, then we will do the raffling subsequently. And here's how generally how the models work. So the hook that we have built mostly utilizing before swap as well as after swap alongside with the swap delta. So during before swap, we will handle the 1% premium within the swap delta, and then subsequently we mint the claim token to represent the ownership of the part of the hook. And then in the after swap, we will then handle tickets double quote issuance as an internal ledger within the hook for each of the LP, which we assume that each of the LPs will have their own ports as well as own branches whenever possible. So separately, we are going to have kind of run a coin job to draw winner for the pool. Basically, it would be likely utilizing ChainLink some randomizer function to kind of help us to draw the winner whenever we see any pool have reached their numbers of ticket that the cap that we would like to target. And then later the user can actually use the claim price function to kind of unlock the pool manager to burn the corresponding claim token and then settle for the price. And for here, we are not settling everything. We are only allowed it to settle just 80% of that. And here's the reason why. So what we would like to achieve for this with this hook is kind of encouraging a much more complete cycle of the flow of the capital itself. So from the initial trade, we will take in 1% of that, putting them into a pot, and then whenever a winner has been selected and claimed the price, 80% they would be able to take 80% of that, and then 20% will then go to the hook. And this is where the magic plans to happen, is that within that 20%, we are expecting roughly 50% will be going back as an additional LP bonus, which is roughly equivalent to additional 0.1 fee, additional fee to the LP, and then subsequently there will be a 30% and a 20% portion goes to a protocol-owned liquidity as well as protocol-free. And specific for POL, we would like to use this hook to kind of bootstrap our own POL such that we will be able to utilize the POL to kind of providing a feedback loop for the stability of that LP, especially when we are talking about stable pairs. So benefit and impact. We have very briefly talks about the stable pairs, the kind of the problem that they are facing, especially when a pairs is kind of unavoidable, like liquid staking token, that they actually needs a stable pair anyways. But having a raffle would potentially be able to help them to kind of mitigate to provide any explicit or external reward for the user. And then second, we can also provide additional small bonus fee to the liquidity provider. And third, potentially we may also consider to use raffle as a mechanics or gimmicks to provide to help the new projects token for them to bootstrap their initial funds. So long story short, in terms of extension, we would like to enable BRL, kind of, just putting ourselves skin in the game. Later, we would like to then further introduce integration with different launchpad as well as LST protocol. And hopefully we could consider to, start studying about, swap to bridges, to kind of, do a little bit of, cross-sync thingy. And the last bit is, given that we are very much focusing on uninformed trader, we think that user experience would definitely be a key to our project success. So that's it. We actually have, I'm not sure I have enough time, but we do have a front end. So if you guys would be, interested to know a bit about how the front end would be running, feel free to go to the links. And that's it from me.
Amazing. Thank you, Dixon. And yes, the front end is linked in the RaffleSwap project page. Great presentation. Next up is UniCow.
Hello, everyone. My name is Sneh. Little bit background about me. So I have been in the crypto space for about 5-6 years now. I have previously worked for companies like Coinbase and MetaMask, and currently I'm working at Espresso Systems. And today I'm going to talk about the project I built. It's called UniCow. It's an actively validated service to enable coincidence of wants matching on any Uniswap v4 pool through v4 hooks. Operators of the AVS run an optimization algorithm to find the best possible matching for users, enabling them to swap at the best possible prices. And it's also economically secured by EigenLayer. So it finds cow matching between any n number of swaps to offer the best prices to the users. It's general purpose and can support any v4 pool. It also falls back to using the v4 AMM for liquidity if a better price through cow cannot be found. So let's go through an example. So for example, there's an ETH USDC pool and the spot price is about 3,000 USDC. Alice wants to sell 1 ETH, whereas Bob wants to sell 3,000 USDC. If they go through the pool, Alice will get about 2,995 USDC and Bob will get about 0.98 ETH due to fees and slippage. Whereas if they're like mashed together, the trading will be between 1 ETH versus 3,000 USDC. So they both will get a better price. So now let's talk about the tech. How does it exactly work? So when the user starts, they can create a swap with hook data indicating that cow is enabled. It will go through our UniCow hook, which will do a no-op and create a task to our UniCow service manager, which is the service manager for our EigenLayer AVS. And it will emit a create task event. The operators of the AVS will actively listen to this event and add this task to a batch. A batch currently runs for about 10 blocks, and once the batch is completed, it will run a cow algorithm to return the best possible combination, and it will respond to all the tasks in the batch. The UniCow service manager will then call settle balances on the UniCow hook, which could potentially call back the Uniswap pool in case there's any swaps which weren't matched using the cow. So why use EigenLayer? Well, EigenLayer helps to decentralize the protocol. It also helps us to not be restricted to one algorithm. So each operator could run their own implementation and find the best possible solution. It is also more gas efficient to do cow off-chain and then settle balances on-chain. I'll go over the matching algorithm in brief. So as we all know, cow is a NP-hard problem and there's no way to solve for optimal matching, and we must brute force it. For the hackathon, I did one implementation of a matching algorithm where I brute force through all possible combinations to find a Pareto efficient set of solution and then choose the one with the maximum output token. So the algorithm starts by creating all possible combinations. And then we filter out for all the possible combinations given these constraints. And then we do a feasibility check. There are certain other constraints as well that we apply to check for feasibility. And then from all the feasible combinations, we find the best combination, where the best combination is simply the combination where the total token 0 and token 1 amount is higher than the AMM with a bias towards token 1. I think I'm going to go over a demo so that it's clearer. I have pre-recorded a demo. So as you can see, the Anvil node is running. I've started the operator of the AVS, and now I'm going to create 3 swaps. The operator will soon detect the task. So here it detected task 0 with 0 for 1 true and amount specified as -10. Then it also saw task 1 with 0 for 1 true and amount specified as -20, and another task was added, which was task 2 with 0 for 1 false and amount specified as -80. So we will see that task 1 and 2 will get cow matched, where task 0 will go through the AMM. It's because of the price, which is 1 to 4. Let's skip over to the analysis part here. So as you can see in the analysis, task 0 got swapped through the AMM, task 1 got cow matched, and it was able to get 1.79 tokens more than the AMM's output. And task 2 also got cow matched, and it was able to get 0.41 tokens more than the AMM's output. We also see that the transaction was successful, so all the balances were settled on chain. Yeah, that's mostly it for my presentation. Thank you.
I love the casual ending. That's mostly it. Very impressive work. This is such a great project. Next up is Mirror.
Yeah, hi everyone. Andrei is here. Can you see my screen?
Yep.
Awesome. Very excited to be here. So I want to present the project called Mirror, which me and my teammate Hadi started building during the Uniswap hackathon. Basically, it's a fully on-chain copy trading app built on top of UniV4 infrastructure and leveraging its killer hook feature to create a seamless, user-friendly, and secure copy trading experience. So not so many average crypto users have real expertise and deep knowledge in trading, but I guess that everyone wants their portfolio to grow. So the copy trading is an extreme demand in crypto and represents a massive niche. If you take a look at the recent trends, you will see multi-billion trading volumes in various crypto trading bots, and it presents a significant market opportunity. But the current solutions are far from ideal. They presented either by centralized exchanges or by crypto bots that often lack decentralization, transparency, security, and suffer from operational downtime. I specifically highlighted one of the recent cases that happened to Banana Gun bot that was drained for almost 2 million USD. So why Mirror is better? It's fully on-chain and transparent. It's built on top of UniV4 bulletproof infrastructure and designed for long-term incentives for both traders and subscribers, which I will describe next. It enables everyday crypto users who lack trading experience to enhance their portfolio returns by following skilled traders. It's providing additional revenue stream for successful traders and boosting liquidity provider benefits through increased trading volumes. So here is the key features that we implemented so far. The traders can trade in existing bootstrapped pools, or they create their own pools for some niche strategies for memcoin trading, bootstrapping liquidity for new projects, and so on. Subscribers are flexible in setting their subscription settings, like they may set stop loss, take profit rules to automatically limit potential loss or profits. And traders get reduced trading fees proportionally to position lock period. And they are flexible to release locked fund before deadline, paying some penalty to liquidity providers. Traders earn profit fees from subscribers, and subscribers can join trader positions directly from a front-end leaderboard. So the Hadi will join me and
guys.
give an overview of the technical part of the project.
Sure. I'll walk you through the flow of the users and also the traders. So this is a really high-level explanation of how the smart contracts are working. Basically, the yellow one is the hook contract that the trader starts the flow with opening the position, which basically tells to the contract that, okay, I'm opening this position with these specific pools that I can trade with this amount of liquidity. And then later, other users will join this position using the subscribe method, which will basically create an NFT for them because it has it's non-fungible to other subscriptions because it has different settings for the stop loss and also like the minimum profit to basically withdraw the subscription and also the timing of the subscription. So basically, a couple of people can subscribe to the same position, and then the trader can start swapping his position from one token to another. Basically, we support one token right now because like adding multiple tokens was really much more complex than just one token, but we are thinking about like adding multiple tokens so we can have like a complete portfolio management from the trader side, and like other people can still join the position even after the trader has started doing swaps. And then basically by calling the swap position, it will basically trigger the after swap function, which will basically go through like batches all of the subscribers' money and then does another swap on top of that money. And we are also planning to use Brevis here to basically calculate what is the amount of money that we can use right now based on all of those constraints that users have put on their subscriptions. And then later, once we have the trade will finish, and later users can withdraw their money using the withdraw or claim function, and we will calculate how much was the profit of the users, also using Brevis infrastructure, and we will send a percentage of that profit to the trader for his actions. Yeah. So basically, for like steps ahead, or like we can go to a lot of directions here. We have a lot of ideas to basically add more features to Mirror. We can utilize out of range trading volume in the pool. So basically, there are like sitting money there without generating any revenue for the users. We can use that to basically leverage the traders and then give some percentage to the owners of the money too. And also we can integrate this infrastructure to other trading platforms, which I think will be really interesting. And also like we can do a lot of social games around it. Like I saw your comments, like points and stuff. We can do a lot of those, and like leaderboards, all of these I think will be really cool. And yeah, if you have any more ideas, or if you want to collaborate with us, we would love to know more about your ideas too. Yeah, thank you.
Thank you, Mirror, and great logo at the top too. Very clever. Next up is Memediction.
Yep. Can you see my screen?
Yes.
Okay. So yes, hi, I'm Matthew. We are Memediction. So meme plus prediction, and we are building a tokenized prediction market on top of Uniswap v4. So the team is Ichi and I. So I am a protocol engineer at Partior here in Singapore, and Ichi used to be from Bybit, a software engineer here in Singapore. So the problems facing prediction markets now is they have limited upside. So if we see poly market, we see that you either get $0 or $1 during the settlement phase. So of course, there are obvious problems for this. One is obvious, you can't get rich quick. Second is more on the liquidity side. So Polymarket uses a central limit order book, which means that you need to provide liquidity around the price range. And this requires market makers, and it suffers for events that have low liquidity in this sense. So Memediction with Uniswap V4 hooks try to solve this problem. So first is with V4 hooks and Memediction, we use a LP with tokenized tokens like ERC20s, which allows you to have 1000x returns in theory. And second is AMM guarantees order execution, unlike CLOBs, because of the price function X times Y curve here. So that's a bit about what we're building, and maybe we can just go to how it works under the hood. So this is a diagram of how it works under the hood. So we have three parties here. First is the creator, and second is the trader. So we have trader yes and no here. And how it works is the creator will initialize the market here on step 1. And when they initialize the market on the prediction market hook, what happens is the hook contract will deploy outcome tokens. So in this case, it'll be yes and no outcome token. So for example, let's say we'll ETH hit 4K next month. So there'll be yes and no, like a prediction market. And then what we'll do is we will seed single side liquidity around a certain price range that we have pre-coded here for the V4 pool manager. And then we also deploy an oracle on that step. We'll determine whether or not the event has happened, yes or no. And then second is once the creator feels it's ready the market to start, he or she will start the market here, and then the market is now open. When the market is open, traders no and yes can buy yes and no tokens, the outcome tokens basically, where they can swap their USDC for yes tokens, and the trader no can swap their USDC for no tokens here. And where hooks come in here is more before swap and after swap. So the hooks come in to lock the actual hook to allow trading during when the market is open, and disallow trading when the market is closed, and for accounting purposes. So let's say trader yes buys USDC and trader no buys USDC with no for no and USDC for yes. So let's say this part is done, and then the creator will settle the market next month and say, oh, USDC, ETH has hit 4K next month. So it's a yes. So yes will be the winning outcome here. So with yes being the winning outcome, the creator will set the outcome as winning, yes. And then afterwards, what happens is the hook will remove liquidity from the losing pools and move it to the winning pool instead, in this case. And then once that's done, the traders of the winning side, the yes token is able to claim the USDC portion with their yes tokens, and the no tokens become worthless here. So that's a brief summary of how the architecture works. So we can do a quick demo video here, what we have. So in here, we're doing a match, basically, a match between Tyson and Jake. So if you watch, the boxing stuff, and then there'll be the winning side will be Tyson here, and losing will be Jake. So the winning side will try to buy USDC or USDM here for Tyson tokens, and the losing side will also buy USDM for Jake. So before this, they don't know who wins and loses, of course. So as we see here, right, the price of Tyson increases after the swap has happened the first time, and also for the loser side, which is Jake's side, we see they try to buy, and then also we see the price going up here, price increase. Yep. So now Tyson and Jake both have Tyson tokens and Jake tokens here in this case. So once the balance is here, you can see 485 USDM from the loser side, and then also the Jake Tyson side has less balance. Now we are now the admin, the market creator here, and we want to do settlement here. So we want to do settlement here, the market settlement for this for demo. We select Tyson to win in this case. So in this case, Tyson wins, and now we can swap and claim Tyson tokens for USDM, and Jake tokens will be worthless here. So in this case, we'll show that, see, Tyson has won the market. You can swap your Tyson tokens for USDM and claim your winning pool. So initially, Tyson side, the winning side has 490 USDM. So they will claim the profit, whoever they have, and they claim the function, and you can see the balance should increase. Yes, so it increased, and the winner got profit from their claim. So in the future, on top of this, after this hackathon, what we plan to build, of course, UI UX is very important here, especially we're catering to more degens, right? In terms of what crypto events are happening, for example, like boxing matches or crypto celebrities and so on. So definitely the degen UX experience is required here. And the second is on the generating revenue. So we realize that the USDM or ETH that we received as collateral can be used to generate revenue where we can stake somewhere or lend somewhere. So that's extra revenue that we can use here. And of course, third is if we're taking this seriously, of course, smart contract audit is required for this part. Yep, so that's a bit about Memediction. So fun fact, Memediction means meme plus prediction market, or it can mean meme addiction. But yeah, that's a bit about us. Thank you.
Great job. Last but not least, Sandwich Protector. Let's see our demo, and then we'll move on to judging and prizes.
All right, so picture, audio are good?
Yes.
Okay. So hi, my name is Alex. About me, I'm a software developer with more than 8 years experience in crypto. I worked on a couple of cool projects. Currently, I'm working as CTO in Barter, which is a solver protocol for Uniswap X and some other platforms, and I'm a huge fan of the X ecosystem in general. So when I visited FCC in Brussels, I had a lot of discussions about MIV there. I actually was surprised how many people still suffer from, sandwiches even this day. So I thought that maybe I should do something about it. And then I visited a Uniswap 4 event about hooks, and I was well hooked. So I decided to implement a hook that, does that. So current state of MIV is, as you can see, we have one bot, which sandwiches about every hour. You can see every block is duplicated, so every transaction is a sandwich. And it's just a single bot, and we have like hundreds of them in the dark forest of Ethereum. So it's better to do something about it. So some prior work about this one is Nestlebin's directional fees. Everybody know what this is, so let's jump directly into the second one, which is called sandwich resistant MM, which is an extension of idea of Vitalik Buterin about how you can split sell and buy prices in order to prevent sandwiches to be profitable. I recommend reading this article. I will link it in the end of the presentation. So the hook idea is pretty simple. We're utilizing the directional fee idea. And because of that, we don't introduce any new curve. We don't alter any internal Uniswap logic. We just add additional fee to make sure that sandwich is not profitable. So for example, how do we do it? For example, user sells some tokens on 0.3 fee pool, right? So it sells then, and then the buy fee is now 0.4 instead of 0.3. Then another user comes and also sells those tokens, and now buy fee is like 0.5 or something. So every time some trade happens in one direction, we just increase fee in the opposite direction. So why this is working? First of all, if rate on a pool is good in one direction, for example 0 to 1, it means that the opposite direction is probably bad, because price can only be good if the opposite rate is actually bad. So this means that if we have any trades in the opposite direction than one that we are currently making, it means that either this is an uninformed user and it just trades unoptimally, or it's a sandwich second part of the sandwich transaction. Which means that if we introduce fees on the opposite direction, and we will be smart about how we calculate them, they won't be noticeable for all the users that are selling our tokens, and they will be almost invisible for user that is buying our tokens, but they will be very visible for the signature. And so it's also important to make it actually a fee because, well, first of all, those uninformed trades happen in real life, and we don't want user to have their transaction reverted for no reason. And second of all is that if we don't do that, if we, for example, just block all the opposite direction trades, our pool will be very susceptible for, denial of service attacks, which is something we don't want. So the fifth calculation is pretty simple. We are utilizing Uniswap v2 formula to calculate which price impact we need to add in order to make the second part of the sandwich unprofitable. Of course, v3 and v4 curves are very different, but actually for fee estimation purposes, it's ideal because it's very cheap and it's very precise. And by using this simplified math, we have just a couple of store operations which cover all our needs, and therefore it's very cheap and very nice. So some demo results. We don't have time for a full demo, unfortunately. So first of all, any special case focused liquidity can be abused. For example, if we have a bunch of very good liquidity and a wide range of very bad liquidity in test, I used like 1,000 times worse rate for the wide liquidity. It's still not possible to profit if you offset user to this bad region. For normal distribution, which is the ideal distribution for two tokens, it's also not possible to abuse with the hook. And sandwicher has to buy at least 80% of pool liquidity in order to try to profit from this, but even then it's not profitable because first of all, it's very unrealistic to have this much funds to actually afford this kind of sandwich. And second of all, we don't consider here at all any extra expenses that sandwicher have to make, because, for example, it's not uncommon to see a 100K profit sandwich that pays like 95K to as bribes to actually make this sandwich happen. So yes, those are results. We have a bunch of tests that show that, well, your pool, one spool was sandwiched, and then we plug in our hook and it's all nice and green. So key properties of the hook: one is it's fully sync, which means that it can be part of bigger trades. As I said, I mentioned before, I'm a solver developer, and this means that having multi-hop trades is very important, and it's even embedded within Uniswap v4 design with all the transient storage and stuff. So yeah, I think it's very important to have this property. It's very, very valuable. Second is it's very competitive. As I said, it's just at a couple of stores. And again, as a solver, I can see that, for example, 5-6K gas difference can be the difference between choosing one or another protocol. So it's always better for liquidity providers to have a competitive contract. Third is it's composable with other hooks because it's simple and sync. You can just drop in or plug it in any other hook, and it will just give you protection. And what I like the most about it is it's virtual, which means that actually what happens is that sandwicher will calculate off-chain what he has to do in order to profit from the hook, and it will find no opportunity, and it will won't send any transactions. And therefore, you just have your regular pool, and this all this logic happens basically off-chain on the sandwicher end. So future work, one is what we didn't quite well investigate is there is an opportunity to add just-in-time liquidity, and maybe it can break some of the assumptions that we are making in order to make this hook work. But it seems unlikely, but it's better said than sorry. So I'd like to check it. And the second of all is that I think we can still shuffle those stores and to make it even cheaper, or ideally like zero cost hook, but we'll see. So references, they will be in the Ethereum hackathon. So thanks for your time. That's it from my side.
Awesome. Thank you so much, Alex. And yes, all the links, feel free to update your project page with the links as well. I think you got a lot of people hungry in the chat, especially if it's lunchtime or dinner time for them. Okay, gonna jump right into, we have a few minutes left, so I'm gonna jump into the end. Thank you everyone for all the wonderful presentations. Give yourself a round of applause for all the work you put in building and preparing for today. So I'm gonna jump towards prizes now. Okay, great. So I want to give a couple of quick remarks about prizes before we actually showcase them, and please remind yourself to mute yourself during this. Okay, so we had thank you to all the judges who were involved in reviewing the projects. We really appreciate everyone who jumped in. Big shout out to Hardik, especially for going through every single project, all the code, all the apps, and really appreciate that, as well as our sponsors who reviewed all the projects that integrated their technology. I know Valentina at Chainlink had 20 plus projects to review. So thank you, huge shout out to Valentina, who I believe is in this room, for putting in the effort along with the Chainlink team as well. Oh, and Ken too. Everyone had an involvement, but I'm just giving special shout out to those that put in hours. There was eligibility. We required everyone to submit actual code, submit a presentation. We had criteria around uniqueness, impact, functionality, and the presentation itself. The individual sponsors also had their own, what it meant to actually integrate their technology. So what I'm going to do first is I'm going to reveal the sponsor prizes. Each of them had full liberty to decide which projects got their pool of 5K and how that 5K was split. So without further ado, we're going to start with Brevis. Congratulations to these 4 teams for winning a prize for Brevis. Shout out Mirror, who presented today, especially. Thank you for all the hard work. And I know all of you guys have already been in touch with Mo on the Brevis team. Some of this judging was a little last minute because of token 2049, but as you can tell, the team was deeply involved in reviewing your project. So congratulations to these 5 teams and the devs behind them. Very excited for you all. Next up is Chainlink. As mentioned, there are 20 plus different projects that were eligible for a Chainlink prize. So huge shout out to these 5 teams for winning a prize. Valentina, I know you're in the room. If you want to say a few words too, feel free to. Otherwise, I'll keep going. But great job to everyone who integrated Chainlink. I don't know if you're in the Zoom. So next up, oh, you are. Oh, here you go. Sorry, I don't know. You're good. Okay. Gonna keep going. The next sponsor prize was Eigenlayer. Big shout out to my lady pools and UniCow. Sorry, I just butchered the pronunciation again. Very impressive work. Very impressive presentations as well. For all of these prizes, each of the sponsors have sent Atrium the prize pool, so we'll reach out directly to get you paid. And now, without further ado, we're going to go towards the prizes from Atrium and Uniswap Foundation. There are 2 images, so be patient. The first batch of winners, Multi-Hook, UniCord, Memediction, RaffleSwap, Sandwich Protector, and Mirror. Congratulations for winning a prize, for being part of the hackathon, and for your impressive work. I believe each of these projects, except Multi-Hook, Antonio Sick, presented today. So big congratulations to them for all the work put in the last 2 weeks. Very excited about what you built. And then there were 3 projects that stood out amongst all of the projects that are 3 of the grand prize winners. So huge shout out to UniCow, my lady pools, and LVR and IL Hedge, our very first presentation, for winning the overall kind of grand prize from the foundation and Atrium. Very impressed by your work, and we will be in touch as well with each of the teams. So great job to everyone who was involved. Very proud of what you were all able to accomplish in just 2 to 3 weeks of building after learning about Uniswap before for the first time. And I want to give another shout out to every other project that wasn't able to present today, and we weren't able to award a prize. You can view them at projects.atrium.academy. We're going to showcase this link for months to come, and you are all pioneers of Uniswap v4. So you're if there's the meme of too early, you were early before I even made it. So big shout out to everyone who participated in this project, and very excited and honored to be able to serve you in your learning journey. And this comes on behalf of everyone on the team. Hardik, Manu, Nate, Anirudh, thank you everyone for all your work. And then lastly, I can't end without a plug. We do work in crypto, so I have to shill. And I'm going to shill cohort 3. So applications are live. Anirudh and Manu are excited to interview you and Nate. Go on atrium.academy/Uniswap. Tell all your friends how incredible an experience this is, and we'd love to see you for the next demo day and hackathon. So congratulations to all who participated, and excited to see what you continue building. We'll share more about graduation. There's a certificate coming, there's swag coming, there is Atrium Punks coming, and you're all eligible for future hackathons as well. So stay tuned for an email about this in the next 2 days. And again, big congratulations. I'm going to read the chat before I end the Zoom call, but thank you, everyone who was here. Okay, I'm just reading the chat. Thank you, everyone. We're going to wrap up. Love the vibes in the chat. I hope we are storing the chat too, so I can read it later. When Atrium token? Love that question. Maybe never, but I don't know. You guys can convince us. Yeah, Hardik, you haven't received swag. I don't have swag either. So I feel you on the pain. I can't wait to rep my Atrium swag in the next hackathon. But thank you, everyone. We're going to call it a wraps. Thank you, Valentina. Thank you, all the sponsors, all the everyone who's involved. You can see all the projects on projects.atrium.academy, Dimitri. Yeah, all of them are there. Let me just make sure we got any questions. Great. Okay. Love all the shout outs, Nate. I hope you're taking screenshots of all the praise. We're going to wrap it up now. Thank you all and hope you have a good rest of the week.